Well, yes, friends. Now I come here to explain you. I will explain you here semiconductor devices. Till now, I have taught you many things about semiconductors, pure semiconductor, impure, it means intrinsic semiconductor, extrinsic semiconductor. Or extrinsic semiconductor, I told you are two types, P type, N type. P-type semiconductor obtained by doping pure semiconductor with trivalent element as impurity and P-type by pentavalent. Now question arises how this doping is done. I gave you some numericals, okay, 1 part per million. It may be increased, may be decreased according to our requirement. Semiconductor electronics has become very wide branch and which is used in communication and made the communication very easy. Initially it was done with the help of thermionic diodes. Their electron was obtained by hitting metal surfaces. Then how this doping is done? Actually, to obtain, suppose you want to obtain N-type semiconductor, we melt silicon or germanium. Mostly these devices are obtained on silicon. Silicon Si is melt. In some furnace we melt silicon, and in that melt of silicon we add the impurity. Atoms in desired quantity. Now the silicon impurity gets mixed together uniformly, and the material, this melt is cooled, and suppose N-type solid is obtained. Now you suppose you have doped silicon with element like phosphorus or arsenic, so you get N-type solid. Now this N-type solid, now we add a desired quantity of pentavalent or trivalent element in melt silicon. The material obtained in form of melt is cooled and we get N-type or P-type solid. I have written deliberately because students do not understand how this is done. There are many methods also but it's a general method. Okay, by we mix pentavalent element as impurity or trivalent in the melt of silicon and germanium. We cool them and obtain p-type n-type solid. This n-type or p-type solid is cut into thin slices. Thin slices. This thin slice of n-type or p-type semiconductor is called wafer. इसको हम कहते हैं वेफर. P type or N type wafer. There are different methods of obtaining wafers, but this is one general method. Every semiconductor device is obtained on these wafers. Whatsoever electron device, semiconductor device is to be produced, that will be produced on these wafers. I hope you have got what is wafer. Now, suppose you want to prepare n-type wafer. So what you will do? Melt silicon or germanium, and a desired quantity of pentavalent element is mixed with the melt, and that get mixed like we prepare alloy. Alloys are the mixture of metals or metal or non-metals, but metal is must. Just like steel is alloy of iron and carbon, and nichrome, I have told you, and that nichrome क्या होता है हमने वो सब alloys हैं, they are obtained the same way. Now what are the devices? The simplest device here is PN junction diode, PN junction, and PN junction, and other are like integrated circuits. Integrated circuit, IC, you might have heard by technician कि IC has burnt, आपकी short होगी सलाह है ना IC means integrated circuit. In 1 millimeter square or 1 centimeter square area of wafer, you may have there thousands of electric circuits. Actually, in early time, soldering was used to connect the circuits together, but due to jerk or melting, those welding done by soldering broken, and so the device get disturbed, working get disturbed. So to avoid that, we use integrated circuit. Actually, in your syllabus only we have PN junction diode. Earlier it was having transistor and gates, etc. So lot of things were there. So here now I will come here with PN junction device. How a PN junction is obtained and what is the function of this. And there are many PN type of PN junction diode. P-N junction diode. वैसे PN junction ही है, but they call diode also because it has two electrodes. Die means two electrodes. So how to obtain PN junction diode? Suppose we have N-type wafer. N-type wafer. The thickness of wafer may be of certain fraction of millimeter or may be of micron thickness. 10 to the power minus 6 meter equal to 1 micrometer. So thickness of these wafer may vary from millimeter to micron, very thin. So suppose we have N-type wafer. Here is N-type wafer. Now this N-type wafer will have electrons as majority charge carriers. Holes will be there, but hole will be minority, I have told you. Now we place aluminum sheet over this and heat the aluminum sheet on this wafer to nearly 850 degrees centigrade. Then due to diffusion some aluminum atom get diffused. Suppose an aluminium sheet is placed on N-type wafer and heated to high temperature of about 850 degrees centigrade. Then some aluminium atoms will get diffused into N-type wafer. So diffusion of aluminum atom, trivalent element, creates the diffusion of aluminum atoms produce a region having holes as majority charge carriers. Majority charge carriers. Try to understand what I am saying. We had initially there n-type wafer. In n-type wafer, we place here aluminum sheet, or there are other methods, and we diffuse some trivalent atom, and that way a region is created having majority of holes, a charge carrier. We can represent it like this. Suppose it is block here. This is the region of here. In one side there will be holes as majority charge carrier. Electrons are also there. Electrons are there, but they are become now in my P region, because hole act as positive charge carrier. So we have developed a P-type semiconductor in a wafer, and electrons are majority charge carrier here. Here are electrons. So this will become N-type semiconductor. So these two regions are created. If you have suppose P-type wafer, then you have diffuse pentavalent element like phosphorus or arsenic. You can place P-type wafer in the vapors of phosphorus. So phosphorus atom will get diffused into P-type wafer, causing a region having majority of electrons. So this way we have got here this PN junction. Here this line is called junction here. The boundary between the two regions is called junction. As soon as this is done, what happens? Here are the holes in majority. Here are the electrons in majority. There are holes, but they are in minority. Here are electrons, they are in minority. There is one phenomena which is called diffusion, and diffusion means movement of particle from higher concentration to lower concentration. So as soon as as soon as the two regions are created, electrons and holes start diffusing from higher concentration to lower concentration. So diffusion take place, means hole start diffusing from P to N region, electron start diffusing from N to P region. The diffusion of hole from P region to N region, the diffusion of electrons and holes across the junction produce a layer around junction where majority charge carriers are depleted. कम कर देना. So we can show here like this. Okay, there comes a region where many charge carriers are depleted. Here are holes. Here are electrons, many charge carrier. This is junction. So this layer depleted. This layer is gold. Depletion layer. As soon as so now I will explain further in next video about PN junction. So as one hole go this way, it neutralize electron and produce positive charge. So मैं लिख देता हूँ ना, due to depletion of electron and holes, there appears holes net positive charge is developed on N side and negative charge on P side. So an electric field. So an electric field is developed across the junction. This electric field called junction field, junction electric field, is only in the depletion layer. Since depletion region is of micron thickness. and potential difference across junction is of 0.5 volt to 0.7 volt order. So the magnitude of junction field is of the order of 10 to the power 6 volt per meter. Remaining thing I will discuss in next video. You please watch this video carefully. When you like the video, please like the video and ask your friend to subscribe channel. Share the video. Thank you.